Hello, I am Sabrina Delgado Arias, and I am with Science Systems and Applications Inc. at NASA Goddard Space Flight Center, where I serve as coordinator for the ISA-2 Mission Applications Program. I will be presenting on our collaboration with the Arctic Council's Protection of the Arctic Marine Environment's Arctic Shipping Best Practice Information Forum. I will highlight our data discovery efforts as well as results and progress of our engagement. I am presenting on behalf of Michael Kingston, who is a special advisor to the Protection of the Arctic Marine Environment's Working Group, or PAME, and also Jelti Renson, who is the PAME project manager. There were a number of people that contributed information to this presentation. We are very thankful to them and acknowledge them at the end of our slides. To introduce PAME, I will begin with a brief overview of the Arctic Council. The Arctic Council is an intergovernmental forum of the 8 Arctic states: Canada, the Kingdom of Denmark, Finland, Iceland, Norway, the Russian Federation, Sweden, and the United States. The Arctic Council also includes permanent participants, which are members of the indigenous communities of the Arctic, and Arctic Council observers, which includes states, non-governmental organizations, and other entities from around the world, such as the World Meteorological Organization. The Arctic Council promotes cooperation, coordination, and interaction among the Arctic states. It generates data and knowledge on issues and trends that impact the Arctic environment and its inhabitants. It enhances and expands long-term monitoring efforts and inventories to address key gaps in Arctic knowledge, and advocates globally on Arctic issues through policy recommendations and international cooperation based on assessments generated by its 6 working groups. PAME is one of the 6 working groups of the Arctic Council and the focal point of the Arctic Council's policy-related initiatives for the conservation and sustainable use of the Arctic marine environment. Advances in technology and changing environmental conditions in the Arctic region have led to a growing focus on the development of its natural resources and the expansion of maritime activity. In 2009, PAME presented the Arctic Council with recommendations on safe shipping in Arctic waters. These recommendations played a key role in moving towards mandatory rules and regulations for ships operating in polar waters. The result is the Polar Code by the International Maritime Organization, which entered into force on January 1, 2017. The Polar Code encourages environmentally sustainable maritime activity and aims to prevent or mitigate any negative social consequences from its expansion. In response to the Polar Code, PAME established the Arctic Shipping Best Practice Information Forum in May 2017. The forum aims to raise awareness of the Polar Code's provisions amongst all those involved in or potentially affected by Arctic marine operations, and to facilitate the exchange of information and best practices between the forum participants. The forum has over 60 participants so far, and this includes NASA. So how is NASA involved? There are many risk factors when operating in the Arctic, including, as mentioned previously, knowledge gaps in understanding the region. Decisions in the Arctic require information at varying scales and time domains, so identifying and including all NASA satellite data, regardless of its characteristics such as latency or spatial resolutions, in Arctic maritime discussions provides needed awareness for decision makers to help improve observations and measurements that contribute to safer navigation and planning of operations. So really, NASA is involved in helping the forum members with data discovery. We want to clarify what data sets are available and planned, and understand from the forum members what are their needs and requirements for improved data. NASA has an applied sciences program, and this program actively seeks to partner with institutions and individuals to increase awareness of its Earth observations and to encourage effective use of data for improved decision making. There are a number of current and planned NASA satellite observations that offer a plethora of opportunities for increased awareness of conditions and changes in the Arctic. I will highlight a couple of these datasets next, starting with MODIS. NASA has MODIS snow cover and sea ice data that has been available since 2000 via the National Snow and Ice Data Center. To ensure continuity of the MODIS data products, NASA also has the Visible Infrared Imaging Radiometer Suite, or VIIRS data, that has been available since 2011. VIIRS improves upon the spatial resolution of MODIS and is expected to continue to operate on different and upcoming satellites well into the 2030s. The maritime forecasting products of sea ice and ocean nutrients from VIIRS can help improve vessel routing and fishery management. And VIIRS also has a date-night band that provides nighttime imagery, which is essential for Alaska during the winter months. VIIRS provides global coverage twice a day with 750-meter resolution across its entire scan. NASA also has the data from the Soil Moisture Active Passive mission, or SMAP, which launched in January 2015. The radiometer from SMAP continues to operate flawlessly, and there is currently a combined SMAP-SMOS sea ice thickness retrieval product developed by the University of Bremen. This product maps thin ice thickness for the winter season in the Arctic and Antarctic and is processed daily. There is also SMAP sea surface salinity and extreme winds data products developed by NASA JPL that is currently available. More recently, we have the launch of the NASA Ice Cloud and Land Elevation Satellite 2 mission, which launched September 2018. ISAT-2 uses a green laser to provide us with elevation data globally for our Earth's surface. The base level product is global geolocated photon data, and it also produces aggregated and gridded photon data for sea ice, oceans, land ice, and other surfaces. There are a number of publications and applied user research related to ISAT-2 observations in the Arctic. You can see some of those publications in the slide, but all publications are available via the ISAT-2 mission website. Now available since August 2020 are overlapping radar and laser altimetry from Cryosat-2 and ISAT-2. ESA raised the orbit of Cryosat-2 to synchronize with that of ISAT-2 and is currently developing an interactive website to allow visualization of where Cryosat-2 and ISAT-2 data products intersect. NASA also has the Global Modeling and Assimilation Office. We highlight here the Arctic Sea Ice Outlook, which are monthly reports released throughout the summer that synthesize community estimates of the current state and expected minimum of sea ice at both pan-Arctic and regional scale. GMAO contributes to the Sea Ice Outlook using its global seasonal forecasts. Finally, we highlight the NASA ISRO-SAR mission, which is expected to launch in early 2023. NISAR will acquire images of ice sheets, glaciers, and sea ice globally. It will measure changes in sea ice, snow extent, permafrost, and surface melting. There are a number of white papers available via its mission website that discuss the expected functionality and application of the data for the cryosphere, among other applications. I have provided you with an overview of some of the NASA data that is relevant for the Arctic. Our goal in liaison with the forum and its many participants is to gain insights into how this data can help support safe and environmentally sound navigation in the Arctic. In 2014, the ISAT-2 and SMAP missions co-hosted a sea ice focus session in collaboration with the U.S. Naval Research Laboratory. The focus session provided a unique opportunity to explore the benefits of incorporating SMAP and ISAT-2 data into existing sea ice research for operational and commercial applications, including how they could suggest best practices for sea ice navigation within the Polar Code, noting that under the United States Arctic Council chairmanship, between 2015 and 2017, navigational safety in the Arctic was a key priority. Through the focus session, it was determined that the satellite data could help inform key decisions, both in pre-planning and actual operations, as to where and when a vessel can operate. Operational limitation of vessels is a key component of the Polar Code for operators, insurance, flag states, and port state control of Arctic state jurisdictions in deciding whether to give authority for the operation in question. The focus session also established early mission engagement with the insurance industry, which expressed interest in collaborating with NASA to help guide policy for the Arctic Polar Code and best practices. One of the key outcomes of the focus session was a meeting planned between representatives of the international insurance industry, NOAA, the U.S. Coastal Guard, NASA, U.S. Navy, the National Ice Center, the Naval Research Lab, and Arctic officials from the Department of State, as well as other United States agencies with interest in Arctic operations. The meeting was held in July 2015 at NOAA offices in Washington, D.C., and it included discussion about the integration of satellite products for developing improved decision-making to help prepare for impending implementation of the Polar Code, and the proposal from the insurance industry for the establishment of the forum during the United States Arctic Council chairmanship. The outcome of the meeting was a continued focus on enhancing maritime safety through a coordinated, all-agency approach, liaising closely with industry, the research community, and many of the current forum participants. In 2020, representatives from NASA's ISAT-2, MODIS, the Global Modeling and Assimilation Office, and Applied Remote Sensing Training Program met with representative of PAME's Forum Organizing Committee to review information on NASA satellite data that may be useful for Arctic navigation. This engagement led to the inclusion of further links to NASA information on the Arctic Shipping Best Practice Information Forum web portal. The web portal is at the heart of the Arctic Shipping Best Practice Information Forum. It has links to authoritative information that regulators, ship owners, ship operators, marine insurance companies, and others can use to make decisions relying on best available information, thereby helping with the effective implementation of the Polar Code. The forum and its participants meet once a year, with a continual onus on enhancing the portal information as it becomes available, including identification of knowledge gaps and areas of improvement. We are currently working with the organization committee to further update the NASA information. During the 4th Arctic Shipping Best Practice Information Forum meeting that took place virtually on November 24 and 25 of last year, forum participants shared opportunities, challenges, and needs for support related to safe Arctic navigation. This included mariner needs, training needs, and opportunities for using new generation remote sensing to improve, for example, nautical charts. NASA is now exploring the possibility of hosting a multi-mission workshop in 2021 with PAME to jointly explore these opportunities and needs. Overall, we recognize that there is a lot of work that still needs to be done and are excited for our continued partnering with PAME for NASA data discovery. So we have reached the end of the presentation. I would like to thank you for your interest in this collaboration and for allowing us to share our experience with you. If you have any questions, please feel free to reach any of us at the emails provided below. And also, I would like to acknowledge Peter Oppenheimer at NOAA, Simon Dwe at NASA JPL, Batuhan Osmanoglu at NASA Goddard Space Flight Center, Dorothy Hall at NASA Goddard Space Flight Center, Woody Turner at NASA Headquarters, and the ISA-2 Applications team for facilitating our engagement and for contributing information to this presentation. Thank you.